purpose of this video is to provide an overview of a subset of the spectrum modulator capability within Spectra. For more detail, you can refer to the Spectra reference manual located at our website, www.syntheticsound.com.au. Generator 1 and Generator 2 each have their own spectrum modulators. With the exception of the unison parameters, the spectrum modulators enable you to control, modulate, or modify the generator's waveform spectrum in real time. The principal design goal of the spectrum modulator section was to enable the user to easily create new dynamic and complex sounds and timbres. In this video, we will be focusing on the harmonic envelope, cross-synthesis, and unison parameters. The morph targets, multi-harmonic, and single harmonic modulators are described in the Spectrum Modulators 1 video. All of the amount knobs in the Spectrum Modulators section are modulatable. In addition, you can also modulate which harmonic number is played with each single harmonic. Spectra has two harmonic envelopes. A harmonic envelope is an array of envelopes which, when applied to the generator's spectrum, provide a contour to the amplitude of each harmonic individually in the generator. This is an extremely powerful feature which enables you to easily create significant spectral movement within a waveform's harmonics. Because each generator has up to 256 harmonics, the harmonic envelopes in Spectra each have 256 DA/DSR envelopes, or one for each harmonic. To assign a harmonic envelope to a generator, simply select the appropriate envelope in the harmonic envelope section of the spectrum modulator. You can freely assign these harmonic envelopes to generator 1 and/or generator 2. Both generators can share the same harmonic envelope. Both generators can also have separate harmonic envelopes or no harmonic envelope at all. Each harmonic envelope also has a range value. The range value determines which harmonics in the generator's waveform spectrum the harmonic envelope will be applied. Basically, the harmonic envelopes are amplitude envelopes applied to each harmonic before the spectrum's harmonics are added together to create the waveform or sound. The harmonic envelopes are applied prior to the amplitude envelopes, so care should be taken to ensure the envelopes are not masking each other. For example, if you have programmed longer release times in the harmonic envelope and a very short release time in the amplitude envelope, you may not hear the detail of the harmonic envelope. Defining a harmonic envelope is relatively simple. To edit a harmonic envelope, select the Envelopes menu item in the Home or Splash screen. In this situation, Harmonic Envelope 1 will be used, so select Harmonic Envelope 1 in the envelope's navigation bar. The Harmonic Envelope view screen is very similar to many of the other harmonic-related screens. The caption bar in the Harmonic Envelope view screen displays information about what you are editing. In this case, the caption bar is highlighting we are in view mode. View mode for all editors enables you to see the entire array of all 256 stage elements at once. In this instance, Harmonic Envelope 1's delay stage is being viewed with Harmonic 1 currently selected. The magnitude or level of the selected stage element is also displayed in the caption. The navigation bar at the bottom of the screen enables you to navigate to each stage of the harmonic envelope. The main display area depicts the rate or level for each of the 256 elements of the currently selected stage. In this instance, we are viewing the delay stage, and it should be noted that all of the rates are currently set to 0. On the left-hand side is the stage rate or level scale. You can select any harmonic by simply clicking on it. To begin editing this stage of Harmonic Envelope 1, select the Edit button. Note the Harmonic Envelope Edit screen displays a range of 64 stage elements relative to the selected harmonic. The scroll bar at the bottom shows your location within the Harmonic Envelope stage and enables you to scroll through all 256 stage elements. To edit stage elements, you can select the element you want to edit and, holding the mouse button, drag the value to the level you desire. As you move around the 256 elements of this stage of the harmonic envelope, the caption displays information related to the currently selected element. If you get to the end of the 64 element window, pressing the Resume button will recenter the currently selected stage element and enable you to continue editing. To copy a single value across a range of multiple stage elements, select the stage element which contains the value you want to copy. Next, click on the rate level value in the caption. Notice how it remains highlighted. This is indicating you are copying the current value. Next, click the selected element again, and while holding down the mouse button, drag the mouse across the range of elements you want to set to this value. Releasing the mouse button stops the copy process, and the rate level value in the caption becomes unhighlighted. The standard Reason Undo feature also enables you to undo any unwanted edits. While editing a stage's elements, you can set the editor to only apply edits to elements fitting a certain criteria within the edit setting. Selecting All will apply your changes to every stage element edited. Selecting Non-Zero will only apply your edits to stage elements which are currently any value other than 0. The Odd setting will only apply your edits to odd stage elements. The Even setting will apply your edits only to the even stage elements. In this simple example, I'm going to use a sawtooth wave as the generator's spectrum in order to enable you to hear the harmonic envelope's effect on the generator's harmonics. It should be noted the harmonic envelope is currently configured with the default settings, which will have negligible effect on this sawtooth waveform spectrum. Now I'm going to program the harmonic envelope's delay stages to introduce a spectral chime-like effect by delaying the start of a number of harmonics playing. This should enable you to hear the effect of the harmonic envelope on the waveform spectrum. This example is just a simple demonstration of the harmonic envelope's capability. Experimentation and creativity can further unlock its potential. The cross-synthesis spectrum modulator cross-synthesizes the spectral output of one generator with the other generator. The cross-synthesis function is most noticeable with any spectrum which is rich in harmonics. As a general rule, the effect of cross-synthesis increases as the amount of harmonic content increases. For example, you will notice the cross-synthesis effect more by cross-synthesizing a SAW spectrum with another harmonically rich spectrum, while you will not notice any effect cross-synthesizing any spectrum with a sine wave spectrum or a silent spectrum. Both generators can cross-synthesize each other. If you are cross-synthesizing generator 1 with generator 2, then the output spectrum from generator 2, which is considered the modulator in this scenario, will include generator 2's waveform spectrum with all of the generator 2 spectrum modulators applied, except for the harmonic envelope. This includes morph target 1, morph target 2, the harmonic multi, the harmonic single, and generator 2's cross-synthesis. In this example, a SAW spectrum will be used in generator 1 as the destination, and a square wave will be used in generator 2 as the modulator without any additional spectrum modulation. The cross-synthesis function applies the modulator spectrum's spectral envelope, which in this example is generator 2, to the destination, which in this example is generator 1. There are three options for how the modulator spectrum can be applied to the destination spectrum: normal, extend, or ignore. These options enable you to control how zero-valued harmonics in the modulator spectrum get applied to the destination spectrum. It should be noted in this example, the modulator spectrum is a square wave spectrum, and so the modulator spectrum has 0 values in all even-numbered harmonics, while the destination is a saw spectrum, which has no 0-valued harmonics. With the normal setting, harmonics from the modulator spectrum with a 0 value get applied to the destination spectrum. You will notice this effectively turns the sawtooth waveform into a square. When the setting is set to extend, the previous non-zero valued harmonic value is applied to the destination spectrum. In this case, you will notice a subtle increase in the resonance of the sawtooth waveform. When the setting is set to ignore, then any 0-valued modulator harmonic is ignored and not applied for this harmonic. You will notice that this setting has almost no effect in this example. This example is just a simple demonstration of the cross-synthesis capability. Experimentation and creativity can further unlock its potential. The unison parameters in the Spectrum Modulator section enable you to thicken a sound by increasing the number of unison voices for each generator. The number of unison voices per generator can be set by selecting the unison mode spectrum modulator and then selecting the appropriate setting in the selector. Spectra enables each generator to play using either 1, 2, 4, 6, or 8 voices of unison. When the unison mode is set to off, only one voice will be output from the generator. The unison tuning knob controls the amount of detune applied to each unison voice. The unison spread setting controls how the unison voices are panned across the stereo field. Finally, the phase setting controls the relationship of the start phase for the unison voices. The default value is synced. Notice when the unison voices are synced, you can hear the synced nature of the voices, which has similarities to a filter suite. The settings spread 1, spread 2, and spread 3 gradually increase the phase difference of each unison voice, diminishing this effect the most with spread 3. The random phase setting uses random values for the start phase of each unison voice, which eliminates any phase sync effect to the unison voices.